Have you ever seriously wondered what it really takes to become a mechanical engineer? Well, today we're going to follow that whole journey, right from day one in a lecture hall all the way to a career that literally shapes the future. Let's dive in.
It all starts with this one giant question. It's the thing that drives all of civilization forward, right? How do we actually build the tools, the technology, and the systems that are going to define our tomorrow?
And the answer really is as simple as it is complex. We engineer it, piece by piece, problem by problem. And today, we're going to explore exactly what that journey looks like for the people who build our world.
So what is this calling? What in the world is mechanical engineering, and why do you so often hear it called the most fundamental engineering discipline of them all?
Okay, so here's the textbook definition. At its core, it's all about applying the basic laws of science, physics, material science, to design and build the moving parts of our world. But honestly, the real magic is in what that simple idea unlocks.
I mean, it's about turning these abstract ideas into real things you can actually see and touch. It's the raw thrill of a McLaren F1 car, for sure. But it's also the incredible precision of a life-saving medical device. You're engineering for pure performance, for deep space exploration, and for sustainability right here on Earth. The sheer scope of this field is just unbelievable.
And that, right there, is the key. This isn't just about gears and pistons anymore. Modern mechanical engineering is all about tackling our planet's biggest, toughest challenges head-on.
And this is so cool. This thinking is now being baked right into the university curriculum. You've got universities like Manchester framing their entire courses around the UN's Sustainable Development Goals. So you're not just learning equations, you're learning how to build real solutions for clean energy, better cities, and a much more sustainable world.
So, if that's the goal, how do you even begin to build that kind of skill set? Well, that brings us to part 2, forging the foundations. This is where the real work starts, building that core knowledge that every single mechanical engineer has to rely on.
Think of your first year as assembling your essential toolkit. You've got to master mathematics, because that's the language of engineering. You'll dive deep into mechanics to understand how things move and, just as important, how they stay together. And you're going to tackle thermofluids, which is the science of energy, heat, and flow that powers pretty much everything.
And this just gives you a little taste of the kind of precision we're talking about. A super complex subject like thermofluids gets broken down into its core parts. Take enthalpy, for example. It's basically a way to measure the total energy in a system. You absolutely cannot design an efficient jet engine or a power plant without mastering concepts just like this one. This is the bedrock.
So, what does it take to actually get in the door? Well, the truth is the entry requirements cover a really wide spectrum. On one hand, you've got a top-tier university like Imperial that might be looking for straight A stars. But then you have other fantastic programs like Sheffield Hallam with more flexible requirements. The main point here is that there are many different paths into this profession.
And of course, there's the financial side of things. This number, £35,700, is the international tuition for just a single year at the University of Manchester. It's a huge commitment for sure, but it really reflects the cost and the value of a world-class engineering education.
Okay, now we get to the really fun part. Section 3, Theory Meets Reality. This is where all those abstract equations and principles finally get their hands dirty.
It always starts with a theory. And this one, the Carnot efficiency equation, is a huge deal. The best way to think about it is like a perfect score, a 100, that is physically impossible for any heat engine to actually achieve. It's the theoretical speed limit set by the laws of physics, and an engineer's job is to get as close to that limit as humanly possible.
But all that theory on a page means nothing if you can't make it work in the real world. This is where an engineering degree really shines. You're immediately applying those ideas in labs, on team projects. You could find yourself on a year-long industrial placement, taking flight testing courses in a real plane, or even battling it out in intense national competitions.
And to do that kind of work, you need an incredible playground. Just imagine testing your designs in a massive wind tunnel, using a professional-grade flight simulator, or programming in an advanced robotics lab. At some universities, you could be working at the National Graphene Institute or even a Rolls-Royce Research Center right there on campus.
Now look, it's also important to be real about how challenging this can be. I think this quote from a first-year student at Manchester just says it all. The beginning can feel totally overwhelming, but that moment when it all finally starts to click into place, that's what makes it all worth it. It's that journey from confusion to confidence.
And that brings us to the final section, launching your career. This is the payoff, right? This is what all that hard work is for.
A mechanical engineering degree is, quite frankly, a launchpad into some of the world's most innovative companies. Graduates are in super high demand, from industry giants like Rolls-Royce, Dyson, McLaren Racing. This isn't just a piece of paper, it's a ticket to a really high-impact career.
And the careers you can go into are so diverse. Yeah, you could become an aerospace engineer or a robotics specialist. But maybe the most surprising thing is that the analytical skills you learn are so valuable that tons of graduates go on to become top-tier management consultants.
Ultimately, it all comes down to professional recognition. An accredited degree is like the official seal of approval from the Institution of Mechanical Engineers. It's that crucial first step to becoming a chartered engineer, which is the absolute gold standard, recognized all over the world.
And that brings us full circle, right back to the beginning. Look, the world has absolutely no shortage of problems. So the only real question is, are you ready to be one of the people who builds the solutions?